Okay. This is from Chapter 11 in OpenStax, the Atoms-First, second edition in chemistry. And this is from Chapter 11. This is number 53. It's a freezing point question, you know, because it has the word freezes in there. It's like a dead giveaway. Okay, a 12-gram sample of a non-electrolyte is dissolved in 80 grams of water. The solution freezes at negative 1.94 degrees Celsius. Calculate the molar mass. So this is really kind of a two-part problem. One is finding out the number of moles based on the difference in freezing point. The second part is using that number of moles and the grams given in the problem to find molar mass. So first let's do freezing point. Okay, in this problem I know that I equals 1 because it says non-electrolyte. Electrolytes are soluble ionic compounds. I sometimes just call them salts. And they break up into particles, ions, in water. So non-electrolyte means it's soluble in water, but it stays as one unit. All right, the Kf is the freezing point depression constant, and this is in water, so I know that's 1.86. In my class, that's not something you have to memorize. If you have other faculty that require that, then you'll need to know that. Okay, so the first thing I'm going to do is convert my grams of water to kilograms of water. And I'm also going to find the delta TF. So what I'm given is the new freezing point. I do have to know that the normal freezing point of water is 0 degrees C. So I have to take that difference, that absolute value difference, which is just 1.94. 0 minus negative 1.94 is just 1.94. So that's the difference. Okay, so in this problem, I'm solving for moles. Whenever I'm asked for molar mass is grams per mole. Grams divided by moles. I'm given grams. I'm told I have 12 grams of the sample in the problem. And so typically what we see in these problems is you find the moles by a calculation. So you're using an equation or series of equations to determine what the moles represented for that amount of grams are. So what I'm going to do is solve for moles. Okay, just give me a second. All right, I get 0.0834. 0.0834. Okay, so that's the first step, is finding the number of moles. You could do this with a freezing point. You could see a problem where you need to use boiling point or osmotic pressure. You could use a number of different problems to solve for moles. You could even use the ideal gas law in some problems. Just remember, we're solving for the number of moles. And then for molar mass, it's grams given in the problem divided by the moles that you solve for. Grams are given in the problem and moles we solve for. So in this case, it'll look like this. Sometimes molar mass is called a formula weight. All right, I get 143.88. Grams per mole. We call that a molar mass. Okay, so in this problem, we use the freezing point equation to solve for moles, and then we use the grams given in the problem and the moles that we solve for to find the molar mass.